the MIkrotik certificate and wish for me to get today the IPv6 one. MIkrotik trainer since 2011, and I also have different professional certificate from other vendors. This is true that my current feeling that MIkrotik is morphing in my blood. I cannot live without MIkrotik anymore. Before we starting, my goal with this presentation just need to show that MIkrotik new features, software and hardware, make MIkrotik possible to join with the high level of networking, even the, let's say, global network or data center and the carrier or big ISPs. And second thing that what I'm trying to do with my presentation, that's always just show the practical things that to be help the attendees to have useful things later to use with their to improve their ISPs or their network. And this information already taken from real case scenario that, let's say, is already working and is not just testing, but is already working and having good result. Agenda will be first, we're starting with the BGP overview, then we'll have to study how we can peer our ISP to the internet from A to Z, and after we proceed to the configuration and then verification of our configuration, how it's work. We'll also have case study with different case scenario, how it's work, and also paint failure case study and how it's recovered. Also, we have little advanced topics that will be covered by BGP as IGP. Next, we'll going to the autonomous system. Actually, we all hear about the public IP, and in a simple way, public IP is actually the IP that's it's also seen with the global routing table and is reachable from any place around the world. How we can get the public IP? We just can reach by regional internet registry like or RARE. And it's almost 5 different parts of the world, like ARIN, RIPE, APNIC, and LACNIC, and AFRINIC, for different parts of the world. For our region, the Middle East and Europe, is controlled by RIPE. Okay, first you have to contact the RIPE, and they will assign you the AS number. Then after they will provide you IP version 4 or IP version 6. Just for information, I think there is no more space for IPv4, so we have to move to the IPv6 later. What is actually the AS number? AS number is the unique number that will be assigned by Internet Registry, and this is identify your IP domain or IP collection, and it's range from 16-bit from 1 to 65 and 535. It's also like IP address have 2 parts, private and public. The public one is started from 1 to 64, 512. The private one will be start from 64, 513, let's say, up to 65, 535. It's a new version. A couple years later, is just introduced it for 30-bit. That's just to avoid if the version, the 16-bit is just almost full. So we can just move to the 32-bit version. And what is autonomous system, if we need to clarify this word, is a group of IP network that's run by one or let's say multiple network operator with a single routing domain, okay? Routing information exchange within an autonomous system required IGP protocol. Routing information exchange between autonomous system required BGP protocol or eGP protocol. So just before we start, let's look how the public IP introduced it to the global network. So we need to introduce or to need to identify our IP network by using our ASNs. Okay, so it means that IP address will be reachable or be reached by our SA number. For example, this is our network. Just we start advertise our IPs through our AS, and this update will reach all the internet place. Then, if one of AS, if we look at the router, this is how we look later on the internet. Destination is our network, and the gateways will be not, like, say, router or anything. The gateway will be the AS number. So our network will be reachable by AS 300, then 200, then our AS number. This is how our IP address reachable through the internet. So now we have the AS number and we have IP addresses. So need to start to peering to the internet. Peering can be done by using BGP protocol. So with the IP stream provider. What is the BGP exactly? There's a language that AS use to talk to each other to exchange the routing information. BGP designed for just exchange the network layer reachability information among autonomous system on the internet. This means how's the internet look with the IP addresses among them in the AS number. Because the BGP information is very, let's say, sensitive or important, that's why BGP use TCP protocol with the port 179 to exchange this information to ensure the information reachability and integrity. So before we need to start, we need to know how many BGP, let's say, topologies possible. Simple one is single multi-homer. This means you have one upstream provider, so one router will be installed at your side, and second router will be installed at your upstream side, and easy, you can just peering. Second one is dual single multi-homer. This means you have two upstream provider, and at your side you have you have two router at your side, and also still you have single upstream provider. This is helpful for load sharing and also redundancy. The third solution is called single multi-homer. It's when you have two upstream provider and still you have single router at your side. Okay. The last one is most common used is dual multi-homer. It means you have two upstream provider and two router at your side. That will be for load sharing and link redundancy. Also, we need to know that how we think we work, how we advertise our IPs. BGP, when we establish the BGP will receive full updates from the upstream providers. After we say that network is convergent, now all the routing table are full. Then only the new updates or the withdrawal routes will be just exchanged between BGP. Second, that in the default things is not always work well. That's why we need to control the updates. This update can be controlled by BGP attribute by filters. For example, for incoming route, it means how we see the external world, how we need to reach the internet. For the outgoing route, it means how the world will see us, how we influence our return traffic that come to our networks. Just for example, that for an incoming filter, for example, we receive two different default routes to our network. Okay. Then we need to use, by default, maybe BGP will depend on its attribute, will use one of them. Maybe we would like to use, for example, the ISP1 as our default route. So it's simple, we can just apply incoming filter and just increase the local preference for the ISP1 default route. So this route will be preferred and will be installed in routing table. For the other side, for the return traffic, that's we need to announce our IP address to the internet. So we need, for example, for this prefix, use the ISP1, okay, as return traffic. And this will be as a backup. So this is, we need to use outgoing filter first, and the most popular attribute that is called a prepend. This means add more copies of AS. For example, for the first link, we will not add any copy. For the second link, we add 5 copies. So how is looked to the internet that the first update is with only 2 AS paths or hops, and for the second one, it will be about 6. So the default selection will be the least AS path. So this will be best path to select it for the routers within internet. Let's say also there's security things we need to take and consider that don't advertise on user prefix. That prefix we are not using, just try to add in routing table and set as backhaul. This is to avoid this prefix to be reachable and for spoofing or for attackers. And second thing, we can establish a BGP connection with a company called, or the group Cyrom. That is, will be send you full Bogon's IP list to avoid access to the Bogon, avoid the traffic to income or outcome traffic to the Bogons. So let's have a scenario step by step how to do this. Let's say our scenario is need to have dual multi-homed and upload sharing and redundancy. We need to have two different upload and use both of upload at the same time. Second thing, we have, again, for a download, both of ISPs and also sharing and redundancy. So first, let's say we have /20y prefix. The best way, we need to divide them to the 8 different subnets. And later, we'll just start from our IGP protocol, then to the through BGP speaker to the internet. This will be how going. So we just divide, for example, 4 from the one upstream provider, another 4 subnet to the different upstream provider. What is the last one? Actually, just a general subnet. It will be work for as a redundant. Let's see how is the routing table will be in the internet. So in the internet, people will see like this. The first 4 prefix will be reachable via this ISP. The second will be reachable via second ISP. And we see 2 different rules. One is active, another in the backup mode. This is for general failover. If, for example, this ISP is stopped, second one will just recover it by general route. This is, as you say, this is how the internet will see us done. How we will reach the internet? There is 2 ways. First way is getting full routing table from internet. Actually, this is need more professional people to deal with the huge of routing routing table. And it's recommended that this routing table don't advertise it to the IGP network. It needs a lot of resources, so only the default route should be received or injected into the IGP. The easiest solution that just we accept the default route from our ISP providers, and this will not need much resources. So easiest ways to do. Second thing that, let's say how is local, we receive 2 default route from our, then inject to our IGP network. And other side, okay, now we have the question that, will default route will be used by default? Again, this is decided with by BGP routes or by OSPF. First, OSPF will, if the cost is same, will do ECMP. So ECMP is not recommended toward the internet. So this can be doing some change or in parameters, like for example, playing with the interface cost, type 1 or as type 2, identifying the route, or the metric, increase or decrease the metric. So this will helpful to have only one active default, or the second will be as backup. And for the sharing, because we will have here, we will have only one active default route. So we can, using the routing policy or routing mark, to use another upstream provider for example, for different prefixes. Let's verify how the connection, how configuration work. Let's say people from internet want to reach this subnet, so they will just reach from this, through this upstream. If they want to reach another prefixes, they will be through that upstream. This is for download. And the recovery stage, if this IPs go down or this connection is a break, just the traffic will switch it to the others. Easy as that. For the upload, for example, these people will just using the routing policy, let's say, upstream provider, and this will be used the default route. What kind of point of failure we have in this scenario? First, if that ISP that's always we use for routing policies go drop, what will happen actually? Let's see here. If it's go down, because the packet enforced by router to use this uplink. So all packet will be dropped here. So internet will be not reachable anymore. The second thing that if this link go down, then we have another internal links go down. What will happen is mean we are just disconnected totally from internet. So what is the best helpful? We need to install between 2 GB speakers, let's say an internal link that we call and enable the eBGP protocol. eBGP protocol will be useful for exchanging routing information. What this router learned will just exchange with this router, and also what this router learned will change to that router. And this should be done first. We need to put the same AS numbers between this BGP speakers, and also this very important, need to enable the fourth self as next hop that ensure that route will be reachable. So let's see how it looks inside the router. The first router will see that we have 2 default routes available. One is active, another is a backup through a different upstream provider. And at the same time, the other router will look like that. Let's see at recovery how it's work. If this uplink is stopped, so the route will be provided through eBGP to another upstream provider, even if you use the routing policy. Second thing that, if let's say I have one upstream provider and one internal link is stopped, so the things will all uplink and downlink will work like this. The second thing that is very important, that if the internal link is stopped, this will not affect your updates within a global, so the traffic will just reach through the eBGP easily. This is very important to take in consider by when we need to install our peers with upstream provider. If you have 2 different upstream providers, it's very useful. And tell you that this is for, let's say, real case scenario that already implemented and has worked very well. We all know that at the start, all people are just opening the eye and listening very well. Things become more clear, and you are happy, and a little more complicated. Then using control, how it look. Before end, this is usually how it looks at the presentation. At the end, all we start to sleep. This is wherever we can see in the presentations. Okay, hop and spoke networks. Most refer to the ISPs, okay, because of it's kind of wide network and based on a star topology, as you see, that's only the hop and spoke. So no other connection to the core network. Let's consider we have such big ISPs and with this kind of topology, if we need to control this ISP by using OSPF. So first we have our core network will be identified as a backbone area. The second thing that, let's say we have data center will be as area 2, and we need to assign as a stubby area, so it means only we receive, let's say, default route with type 3 LSA, the Sami network. And the other part of network will be just divided to different area, and each area will have area. This is a simple way how to control big, let's say, large ISP with the OSPF. And as you see that here is not, let's say, a redundant network. We have different point of failure in this scenario. Here we just add more links to, let's say, to have more redundant link for even in the core network and the outside. So what we get that OSPF will provide a redundant link as well, and the redundant link will be active only if the main link goes down. Yes, not simple to have both links working together, okay? It needs more, let's say, implement different, let's say, multi-instances OSPF. Let's compare OSPF with BGP if we need to lead this network. So the OSPF vs BGP, or we call infrastructure vs policy. First, we start OSPF built its, let's say, LSDB or let's say database based on network infrastructure and connectivity. Second things that BGP built its routing table from only received update. Second thing that OSPF make routing decision based on network connection and cost, and BGP make routing decision based on route attributes. OSPF save all learned info in the LSDB. It means it have its own routing table, but BGP, whatever he learn, he will install directly to the routing table. OSPF install single is offering single route to the routing table. OSPF have same cost route, so he will provide ECMP. BGP will he will just install and offer all the learned route direct to the routing table, and maybe one will be active and the rest will be as a backup. OSPF network convergence based on, for example, first word wall, then a new calculation, then a new installation in the routing table. But BGP network convergence will based on only active the available routes. One thing that BGP have that OSPF don't is BGP can carry multi-label protocols, okay, and advertise to the other networks. It's possible to have hybrid configuration. OSPF and BGP together, yes. OSPF can provide end-to-end network connectivity within network. BGP can take they take the IP datagram for the users, and it can be led by with the powerful policy. And keep in mind, this will be not simple at all. Need, let's say, enough information how to do this. The reasons that we need to implement BGP instead of OSPF or as IGP there's large-scale BGP is simple than large-scale IGP. Okay, because the BGP is already designed to build a big, let's say, hierarchical network. Let's say the biggest is internet routing domain. BGP can provide layer 3 and 2 VPN services over network, as we call BGP-MP multi-protocol. A flex routing policy that OSPF does not. Load sharing within link redundancy over multipath. Minimizing the network resources, and also speed up routing convergence. This is just simple how things work in the routing table. That this is exactly the time for the BGP how to recover the connection, and this is the OSPF. And we can just for test, we have a 12% packet loss with BGP, and OSPF we have about 30%. Another question is that which one will be used if we need to use BGP as IGP? iBGP or eBGP? This is very important questions. So first we need to just see the difference. iBGP required full mesh and the routed network on the local network, also with recursion route. eBGP not required full mesh. This is first thing. Second thing, IGP is required to provide full mesh like OSPF. We need another routing protocol that it will be with iBGP to provide full mesh connectivity within network. But eBGP, IGP is not required when we use eGP within network. No meaningful metrics is carried by iBGP advertisement with AS autonomous system, but with eBGP carry all BGP attributes to choose the best path. This is the most important. So it's highly recommended don't use iBGP as IGP. Let's have different case scenario. First, we start with very small things that we have this topology. We have different router need to provide, let's say, a redundant link. So the configuration will be easy that we'll assign ASA numbers first for each node, then establish the eBGP connection. So everything will work automatically with selecting the main path or redundant path, or can be load sharing together. Another small scenario required is connection redundancy and load sharing. So same, just we identify the AS numbers, then establish the BGP. For little bigger scenario, for example, is required, let's say, load sharing and redundancy. This is the point of BGP that we can just deal directly with the prefixes. So if you have, let's say, /22, just we can divide it in smaller, then we can load the prefixes through different links. And also redundancy will be automatically provided by BGP. Let's go for the bigger networks, okay? We have same network, and let's see how things will work. Just we first assign AS numbers for each node or each, let's say, POP, okay? Then establish the eBGP connection for each our connection. This is how it's going to look. Let's say it's not easy as is looking here, but after you finish, I think will be 100 under control. Let's say have more. What's the difference now? We see here that each POP or each line is now separated. What with BGP can do, just we have different also or more connection redundancy within network. As you can see, we can connect as much as possible our network to provide more redundancy and load sharing. Now let's say our topology is full meshed. It can be, and we had different redundancy for our links. The questions. We have a subnet here, and the question that how is the routing table will be look? Can anyone tell? How many different paths we will have to reaching the network in here in this router? How many routes will be available? Anyone? Only one. Let's say the action. We have 3 different paths. First, the one is here. Second, through this one. And the last one is here. Another questions. For this network, again, how many different paths will be here at this router? Again, only? No, it will be 4 available. Yes, 1, 2, 3, 4. Just let's see, again, this network will be advertised through all this network to reach the core network. So this router will receive update from this one, from this BGP, and from this BGP. So 3 updates he will receive. So by your BGP attribute, you can choose the best one, and the rest will be as backup. This is the first thing. And for the second scenario, second scenario, this again will be reached over all ring to the core network. So we receive 1 update from here, second update from here, third, and then 4. We have 4 possible connectivity for this network. So this is what let's say, very good for BGP. And it can be, again, as it can begin, is the question that can we use all 4 routes together, or it will be only one active? Again, it's only one active. Any other answer? We can use 4 of them together if we need, for example, divide them to the smaller network, for example, for load sharing. It's possible to this with eBGP, yes. Thank you. If you have any questions.